Hello, good morning, good evening, and welcome to the session to talk about automating API management using Kong and AWS. Hope you're enjoying the great session lineup today and learning more on automation. We have a lot planned in next 20 minutes or so, and I'm excited to share this learning with you all here. So let's get started right away. A quick introduction about me. I'm Anuj. I'm a container specialist solution architect here at Amazon Web Services. I have little over 15 years of hands-on experience in application and infrastructure development. I'm really passionate about building large-scale scalable solution for customers and developers. I've worn multiple hats ranging from lead software developer, architect, engineering manager, product manager in a variety of industry ranging from financial services to retail. When not building with my customers and partners, I love spending time with my 3 years old daughter indoors and outdoors whenever Seattle weather permits. So let's see the topics that we will learn in this session today. We will first have a quick primer on characteristics of a microservice and then look at the key tenets to consider behind any API design. We will then see conceptually how to operationalize an API leading way for API automation. We will then dive deep into and apply and validate each 12-factor app development principles for Kong on AWS. All right, coming to primer. So what do our customers want in a typical microservices or a modernized application? Whatever the legacy, whatever the agency, organization, or institution, our customers want to become more agile so that they can innovate and respond to changes faster. The applications that organizations need to build today are vastly different than it used to happen in past. They need to scale quickly to potentially millions of users, have global availability, manage petabytes and if not exabytes of data, and respond in milliseconds. These type of applications is what we call it as modern applications. They cover a variety of use cases such as web and mobile backends, IoT applications, AI ML workloads, batch processing, platform as a service solution, microservice backends, and more. When customers modernize, they enjoy the fullest benefits of the cloud, maximizing agility while minimizing operational load. Any microservice tenant should account for mainly 5 different vectors, in my opinion. Firstly, their architecture pattern should define the bounded context and account for services being modular. Operational model should be as serverless as possible and as automated as possible. Thirdly, developer agility as automated, abstracted, and standardized as possible. Fourthly, data strategy should be distributed and fit to the purpose. And lastly, management and governance should be dictated via programmatic guardrails. When we apply 12-factor app design principles later in the day today, we will explore how Kong and AWS fits in these key tenets. Modernization and specifically the adoption of serverless technology really changes how you work, and this applies to anyone who interacts with the application. With serverless, you're adopting a new application architecture triggered by events and rethinking how you store the state. You're also rethinking how you operate your applications. We have long said that Lambda and the rest of the serverless portfolio, traditional components of application serverless application operations like server management are entirely eliminated. Over the years, many media and analysts have positioned that adoption of serverless technology would result into operations-free application or referred as no-ops. However, no-ops is not a reality today. What is true is that the role of application operators is different. Today, let's look at what are these changes and how it look like and how that impacts the builders and operators in your specific organization. One of the most important ways that we ensure safety and security is through guardrails. Let's look at the philosophical approaches to modern operations. One is a free-for-all, and other is a central control. No one actually considers the free-for-all approach to operations or security, but it is a good illustration of the two extremes available at a philosophical level. Let it be fast chaos or slow order. You can let developers do whatever they want to do, and they will indeed release fast. You will probably also release bad code, reduce application reliability, and get into some kind of troubles. On the opposite end, and to be more realistic scenario, we see customers managing operations centrally. They take control of the release pipeline, the process of provisioning resources, securing applications, and troubleshooting. This is much lower risk, but also a lot slower due to dependencies and time lags. But at Amazon, we do not give in to the tyranny of or. We want it both ways, fast and safe. This is why we use the concept of guardrails. Guardrails are usually expressed as code, and guardrails are established and standardized through a centralized team and delivered and up to date to the team of builders in an automated and a programmatic way. There are a few different areas we tend to see operators work in. The new role of application operations in a modern serverless application is to set guardrails for these areas and to deploy updates and changes throughout the organization. Often in this specific model, operations team become a part of central platform team or cloud center of excellence. Now, let's dive deep into applying 12-factor application development principles to achieve API automation using Kong on AWS. A typical installation of Kong Enterprise on Amazon Elastic Kubernetes Service, or EKS, involves installing the Kong control plane and Kong data plane on one or more clusters spread across multiple availability zones, or even regions, or even split between on-premise and AWS, depending on your specific use case. Kong is a Lua application designed to load and execute Lua or Go modules, which we commonly refer as plugins, which is typically installed on the data plane. Kong provides a set of standardized Lua modules that get bundled with Kong Gateway. Plugins provide advanced functionality to extend the use of Kong Gateway, which allows you to add more features to your implementation. Customers typically use services such as Amazon Elasticsearch, Elasticache, Amazon CloudWatch, Amazon Cognito, Amazon RDS, and AWS Directory Services to get more managed and highly available solution out of the box. This actually lets Kong focus on API management and leverage AWS services for non-API management specific activities. Now let's apply 12-factor development principles on an application leveraging Kong for API management. If you use this methodology, you can make scalable and resilient apps that can continuously be deployed with maximum agility. 12-factor design also lets you decouple components of your apps so that each component can be replaced easily or even scale up and down seamlessly. Because the 12-factor apps these 12-factor design principles are independent of any programming language or software stack, it can be applied to a variety of apps, which in our case, we will limit to an API which is using Kong for API Gateway. Now, so first up, the code base. You must manage all the code in a central source control system and use one code base per application. This means if you have two container application in your solution, they should live in two separate code base repositories in a version control system like Git. Storing the code in a version control system also enables your team to work together and collaborate together by providing an audit trail of changes to the code, a systemic way of resolving merge conflicts, and even the ability to roll back to a previous version. Specifically for Kong, the entire infrastructure can be provisioned using AWS infrastructure as the code services such as CloudFormation templates, AWS CDK, and in the context of Kubernetes, using Helm charts and Kubernetes manifest files. Moreover, Kong provides the ability to import the API specs directly from version control. Next up, dependencies. The dependencies of the application should be declared explicitly, and no dependency can be assumed to be coming from the execution environment. In a container-based application, you can handle this concern by using Docker files. A Docker file is a text-based list of instructions to create a containerized image. You can declare your application dependencies in the manifest file of the programming language's packaging system and install them using the instructions in the Docker file. Now, specifically for Kong, offload non-specific application bounded contexts like PCI compliance, monitoring and logging, authentication and authorization, traffic control, etc. to plugins. Offloading these components to Kong plugins allows customers to focus more on writing code for your specific APIs and the business facade of your interest. Next up, configuration. So the 12-factor methodology prescribe a strict separation of configuration from code. Configurations that vary among deployment environments should not be stored together with your application code. The code for your applications must be the same across all the deployment environments. The specific configuration of your application is provided by deployment environment using environment variables. The different stages of your deployment pipeline can provide the environment-specific configuration. You can use services like AWS App Config, which is a capability of AWS Systems Manager to create, manage, and quickly deploy application configuration. You can use AWS App Config with application hosted on EC2, Lambda function, containers, mobile application, or even IoT devices. Specifically for Kong infrastructure, use Helm charts and Kubernetes manifest files to install the gateway and plugins on EKS. Moreover, instead of using specific APIs, use the Kubernetes manifest files to deploy the Kong plugins itself. Next up, your application must treat any service that it uses to perform its business function as an attached resource. This may be an RDS database or a DynamoDB table or an S3 bucket or even a non-AWS service for that matter. The attached resource semantics prescribes that these resources are made available to the application as a configuration. Your application will be aware of the attached resource, but not tightly coupled to it. Now, for Kong, use managed services such as AWS ElastiCache for caching routes, discover and visualize data using Elk Stack, and use Cognito or AWS Directory Service for the AWS Directory Services for authentication and authorization. Next up, for building, releasing, and running. AWS Code Pipeline provides a mechanism to separate the build, release, and run stages for a deployment, as typically recommended by the 12-factor application. When you're releasing new code to a target execution environment, you will first package the application code as a deployment artifact. Specifically for Kong Gateway, build the API spec, fetch from the version control, use AWS Code Build, and deploy to Gateway. And this entire end-to-end experience of automation can be orchestrated using AWS Code Pipeline or CI/CD tool using Kong admin APIs. Next up, processes. Your 12-factor application should be built as one or more stateless processes. Containers are designed to be stateless and immutable, and it is recommended to run one application process per container in most of the use cases, as state must be persisted in a backing store like backing store like database. The memory or the local disk of the execution runtime should not maintain any persistence between two incoming requests. Again, if you use plugins, configure them to use the external services as applicable and where possible, so that the gateway itself stays as stateless as possible. For example, instead of using PostgreSQL data store locally, which houses the critical key working components such as config store for Kong, though it possible, but for operational ease and an HA solution, it is recommended to offload to a highly available service like Amazon RDS, which can even do automatic backups, restore, and failover, and that makes sure that the gateway is always up and running. Next up, port binding. So 12-factor apps should make themselves available to other applications by port binding or binding port to the execution environment. Container-based application expose their port through the expose command instructions in the Docker file. Now for Kong, use AWS Elastic Load Balancer, which exposes gateway, proxy manager, proxy manager portal, ensuring that these components are all accessible at different ports. Container-based application can scale out by spinning up more instances of the container process. This is the model of scaling. This is the model of scaling typically prescribed in 12-factor methodology as well. Now, for Kong, use a horizontal pod autoscaler coupled with cluster autoscaler for control plane and data plane scaling, ensuring that not only Kong pods scale out, but the underlying systems also scale up based on increase in the traffic. We are going to skip the 9th and 10th design principles, which is disposability and dev parity, as it is either not applicable in the context of Kong or it is a property of Kong's Lua code, which is addressed natively by the app itself. So coming to the next stop, which is logs. Treating logs as a continuous system of events instead of static files allows you to react to the continuous nature of log generation. You can capture, store, and analyze real-time logs to get meaningful insights into application's performance, network, and other characteristics. An application must not be required to manage its own log files. Now, specifically for Kong, you can use the plugins that empowers customers to send TCP logs, UDP logs, sys logs, and all the relevant metrics associated with your specific API, which is passing through Kong Gateway to a destination of your choice. And finally, the last principle, which is the admin processes. Now, any admin or maintenance task for the application should run in an identical environment of that identical environment to that of an application. These maintenance tasks are usually short running and only intended to support the normal business functions of the main application. Now, specifically for Kong, use admin API for admin functions and limit the use of the admin APIs bound by authentication and authorization against the respective data store. All right. So with this, we are actually at the end of the session. Hopefully, you find this talk to be useful and looking forward to take questions if there is still time left. I guess we still have 5 minutes left here. So as a next step, I would actually encourage everyone to try installing Kong on AWS EKS by yourself and give it a try to see how easy it is to do the API management using Kong on AWS. Kong is an advanced ISV partner with AWS, and we are collaboratively in works already to create hands-on workshops and quick starts, which a customer would be able to quickly use it and get up and running as soon as possible. So stay tuned for that. Again, thanks a lot for coming to the session, and happy automation, and looking forward to chatting with you all today. Thank you. All right. So I see a question which is, how about testing regarding the principles presented? Where should it be located? Uh, I think that's a great question, to be very specific. How about going about testing these principles? So I think it's a design methodology that needs to be applied to the respective applications, along with along when we are designing the specific use case for the customers, as in what is the design for Kong that should be implemented on AWS. So it really comes down to actually in the design phase itself, that how are we actually going about implementing the specific use case that is in question. But overall, I think it's a great question to an extent that I don't think we have an automated way to be very specific to test whether your application and your and Kong gateways installation on AWS fits to these design principles. And I would say that this is more of the implementation level detail at the customer specific use case, because these are general design principles and this can be extended to be applied to a specific use case. So depending on how you are actually going about implementing the solution, there are ways to actually create automated testing, but again, it has to be fitting to the use cases that you have, that you are actually addressing the gateway and applications, to be very specific. All right. With that, thank you, everyone.